Hello all. Today I want to talk to you about AND, OR, and NOT gates, inverter gate. We already talked about inverter gate in class, but I'm just going to give you a little bit of the review. This is what the inverter gate looks like, and it is very often called NOT gate. So every once in a while in the quiz I will ask you to give me an inverter gate, and I will be asking for the word NOT. That's pretty common to refer to it as a NOT gate. So the inverter gate does exactly what you would expect it to do. It inverts the input. So if you guys remember, we have two types of inputs. Either you have a high or you have a low. What you don't have is an in-between. So what NOT gate does, if you give it a high, it gives you a not high. That means a low, right? So if it gives you a 1, it gives you a 0. If you give it a 1, it gives you a 0. If you give it a 0, it gives you out of 1. So over here you can see a truth table for the NOT gate. And the inverter truth table is very, very, very short because you have only one input. And that means you have only two options, right? You either give it a 1 or a 0, a high or a low. So that's pretty straightforward. One thing I want you to be able to do is to actually give your make statements with your gates and figure out which gate is coded in which statement. For example, here I have a statement, I like cats. And I want to put in an inverter gate in there. So inverted statement would give me I do not like cats. Please notice that this is not I like cats. That's too much information. Maybe I hate cats as an animal. Maybe I just don't know how to cook them, right? But all I have is that I do not like cats. That's all, okay? So you either like cats or you do not like cats. There is nothing, there is no other information given. When you say you hate cats, you give too much information. I do not like cats. That's it. So generally speaking, if you're reading a task and it has a not in it, that's basically a dead giveaway that there is an inverter somewhere in there. Okay, so next one, let's talk about the AND gate. The AND gate has two inputs. And in order for your output to be true, to be high, to be true, both of those inputs also have to be true. So the best way to understand this is to get an example. So it's for me to give an example. And a good example I have is the check engine light and the gas sensor. One of the reasons the check engine lights come on is the gas pressure sensor in your gas tank. And if that sensor reads high pressure and the temperature is about 40° Fahrenheit, only then will it send out a signal to turn on the check engine light. So let me type up this example real quick. All right, guys. So as you can see, If you look through this truth table and look at my example, you will see that this is all true, right? So for example, here is my option A. My gas pressure sensor reads low because I got a 0. My temperature is below 40. Well, my output over here is the check engine light, and it also reads a 0, of course, right? There is no problem with the pressure, and the temperature is less than 40. Well, over here, the gas pressure reads low, but the temperature reads high. Well, once again, there is no reason for check engine light to turn on because the gas pressure is low. That's what it's supposed to detect. What about over here? The gas pressure is high and the temperature is low. So it outputs a 0. Honestly, in that particular gas pressure indicator, that option never happens because as the temperature drops, the gases condense. But for the sake of the argument, should this ever happen, this would also be true, and it will not turn on the check engine light. And of course, when both of them, the gas pressure is high and the temperature is above 40, you will get a check engine light. And this is just pretty straightforward. Okay. Well, the next gate I want to talk about is the OR gate. And you can see the OR gate over here. And OR gate is a choice, this or that. So for example, I send someone to the store and I tell them, bring me a hamburger or a hot dog. You will notice that it is true. If the person brings me neither, he of course didn't do what I asked him to do. But if he brings me a hamburger, that's fine. If he just brings me a hot dog, that's fine. If he brings me both, even better. So this one is either or both. And that will all of those options will give you a 1. And only if neither of them are true, I didn't get a hamburger or a hot dog, only then will it give me out a 0. All right, so I typed all of this up, and you can see it's just what I just said, right? No hamburger, no hot dog, output 0. Just hamburger, output 1. Just hot dog, output 1. Hamburger and hot dog, output 1. You can make all sorts of combinations of these logic gates to do all sorts of problems. And generally speaking, just about any circuit that we will do in next month can be done using AND or NOT gates. In general, any circuit that doesn't have memory can be made using all of those gates, just those 3. You don't really need any more, any other ones. These 3 will work. So that's really all I wanted to say on the subject of these gates.